All right, today's lesson is 331 fraction division, and you'll be copying today's notes on page 23 of your toolkit. So let's go ahead and label this as 331 fraction division. Okay, so again, page 23 of your toolkit. So the problem starts off in this chapter, in this section, with three students who are working on a problem of dividing two fractions. You have 1 and 3/8, which is a mixed number, divided by 3/4. Now, the three girls who are working on it are Hui, Madison, and Ramona. Ramona's method is called the number line method, which is a way to sort of work out a division problem asking how many of one number is in another number. But we're going to skip that for now. We're going to talk about today Madison's method, which is a common denominator method, and Hui's method, which is called a supergiant one. And we're going to explain both of those methods, and you'll be able to practice them once we get the independent practice today. And we'll do a few examples. So the first problem is the mixed number 1 and 3/8 divided by 3/4. Now, first, in order to divide these fractions, we need to change this to a fraction. So if you remember how to change a mixed number to a fraction, go ahead and do that. So we have 8 times 1, and then we add the 3, and then we put it over 8. Okay, so this becomes 11/8 divided by 3/4. So this is our new problem, which is pretty much the same fraction division problem. All right, so the first method we'll look at is common denominator. And this method is pretty much what it says, what's in the name. You have 11/8 divided by 3/4. So once you have those fractions, we would now make sure that both of these numbers have a common denominator. So the LCD between those two numbers, or those two fractions, is 8. So now we put, this number's already over 8, we put 3/4 over 8, and that gives us a new fraction. So our problem becomes 11/8 divided by 3/4 becomes, well, if you're not sure what 3/4 is as an 8, so we would then use the giant 1 method and say, what is 3/4 if we have a denominator of 8? Okay, and we use that giant 1 and think, well, we multiply by 2, multiply by 2, so 2 over 2 is our giant 1, and that gives us 6/8. All right, now our answer to this problem is the numerators. Okay, so if you look at the numerators of both of these, you have 11 and 6. And there's the answer. So the key behind the common denominator method is once you find a common denominator and you rewrite that fraction as a new fraction division problem, there's your answer on the top, 11 divided by 6. Okay, so let's put that answer is on top. Okay, that's the easier way of saying your answer is right there in the numerators. All right, so let's go ahead and put that in. Let's go highlight that because that is a very key element to this, is your answer is on top. Okay, now the logic behind this is if you have 11 of something and 6 of something and you're comparing them using division, it's 11 divided by 6. If I have 11 ones and I'm dividing by 6 ones, we all know that 11 divided by 6 is 11/6. If I have 11 halves and 6 halves, then I have 11 divided by 6 because it is a proportional ratio. So that does follow mathematical properties, but the easy way of looking at it is your answer is on top. Okay, so your answer is 11 divided by 6, which is 11/6. We all know that a division problem is just a fraction. A fraction is a division problem. And I repeated that several times during the first week of school. So we changed this to a mixed number if you wish. 11/6. How many 6's are in 11? There's 1, and you have 5 left over. So your answer is 1 and 5/6. So that is the common denominator method in a nutshell. So the second method, this is method 2, is called the supergiant one. Now we all know what a giant one is. A giant one is a number over itself, because we know that any number divided by itself is 1. So we are going to use that logic to do the supergiant one. Now, let's go ahead and go to the original problem. We already know what the answer is going to turn out to be, so here's the work that would get us that. So we'll go 11/8 divided by 3/4. We'll start from the beginning. 11/8 divided by 3/4, and we don't even need them to have the same denominator. Now, the way we do the supergiant one is we basically write this division problem as a fraction, because a division problem is a fraction. So we would write 11/8 divided by 3/4. So you see there's a fraction over a fraction, which we don't usually write numbers like this. We wouldn't leave it as that if that were an answer to a problem. But for these purposes, we're going to do this. Okay, so yesterday in your in the homework that was actually on Monday, we worked out some problems about reciprocals, and those are called multiplicative inverses. So the inverse property says if you have a number such as 3/4, and you multiply it by its reciprocal, which is the multiplicative inverse. So the multiplicative inverse of 3/4 is, if you said 4/3, you are correct. So when I multiply any two reciprocals or any two multiplicative inverses, I'm going to get one number over itself. 3 times 4 is the same as 4 times 3, and 12 over 12 is equal to 1. So this is a 1 in the denominator once I multiply that. But the thing is, I can't multiply a denominator in a fraction by something without changing the whole fraction. So I must do the same thing to the top, to the numerator, in order for this to be an equivalent fraction to the original fraction. Here's what I mean. So if I change the denominator by multiplying by 4/3, I must change the numerator by doing the same thing. So there's our 1. Okay, so same thing as multiplying the bottom and the top by the same number, and that gives me an equivalent fraction of 6/8, which is equivalent to 3/4. So here's my 1, 4/3 over 4/3, and so this fraction that I'm going to get is going to be equal to 11/8 over 3/4, because I'm going to multiply it by, here's your giant 1. This is a supergiant 1. So now the procedure here, or the method here, was we had to make the denominator equal to 1. Okay, so remember that. We make the denominator equal to 1. Now, whenever we have a number that has a denominator of 1, like 5/1 or 6/1 or anything over 1, it just equals that top number. 6/1 is 6, 5/1 is 5. So if we have this right here over 1, our answer is just going to be whatever this is, whatever 11/8 times 4/3 is. So once we find out what is 11/8 times 4/3, we can just pretty much ignore the denominator. Okay, so here's our new problem. Our new problem is 11/8 times 4/3 over 1, which we can ignore, and that is our new problem. Okay, so we're going to then call this 11/8 times 4/3. So our original problem of 11/8 divided by 3/4 became 11/8 times 4/3. Now this may look familiar to some of you who in elementary school learned when you divide fractions, there's a little chant or a method that you can use, which is called keep, change, flip, or same, change, flip, which means we keep the first number the same, we change the division to multiplication, and we flip that second number. Okay, now what your teachers may or may not have told you is by doing same, change, flip, or keep, change, flip, you're not really following any mathematical properties. Just by arbitrarily changing a division sign to a multiplication sign, there's no property that says you can do that unless you're multiplying by the reciprocal. And then making that reciprocal, changing that number again. So by doing keep, change, flip, you're actually using the inverse property, which says any number times its reciprocal is 1, and you're using the identity property, which says any number times 1 is that number itself. So let's find out what that number is. So we go ahead and we multiply these. Now we know that we can use the butterfly method, or we can cross reduce, and so this number here, 11/8 times 4/3, we can reduce the 4 to a 1, and we can reduce the 8 to a 2. And now we can multiply straight across, 11 times 1 and 2 times 3. So that gives us 11/6. Okay, so then we see our answer matches up with our answer here, 11/6. And that's the supergiant 1 method. Okay, so let's change this to 1 and 5/6, which is the mixed number version of that. Okay, so let's do a little practice now with this. So feel free to pause the video at any point if you want to work it out, and then play it to check your work. Okay, so our first example, we're going to do 4/5 divided by 1/2. 4/5 divided by 1/2. Okay, so first we're going to use the common denominator method. We'll just call it CD. Okay, so our common denominator method means we're going to find the LCD of both of these. Okay, so go up to your notes and check. Okay, so we find the least common denominator and we rewrite it, and then our answer is on the top. So the least common denominator is, go ahead and write it down. And if you said 10, then you are correct. So rewrite those fractions using tenths. Feel free to use your giant 1. Okay, so what we're going to do here is 4/5 equals what over 10, and then 1/2 equals what over 10. Use your giant 1. Okay, so times 2 times 2, this is 8, times 5 times 5, this is 5. So our new problem is 8/10 divided by 5/10. And therein is our answer. Our answer is 4/5 divided by 1/2 is equal to 8/5. Common denominator method. Okay, and let's try the supergiant 1. We'll call it the SGO. Okay, so supergiant 1 method. Let's go ahead and use the same. Since we already know what the answer should be, we'll see if our answer does end up being that. Okay, so supergiant 1, we have 4/5. We are dividing by 1/2. So that's 4/5 over 1/2. Right? Okay, so remember, what number are we looking to be in our supergiant 1? We're looking for the reciprocal of that denominator. So what is the reciprocal of the denominator? Okay, so let's put that note down just for ourselves. Reciprocal of the denominator. All right, so the reciprocal of 1 over 2 is, if you said 2 over 1, you are correct. So that is our supergiant 1. Okay, now this will give us the new problem because we can pretty much ignore this. This is 1. And now we can just multiply straight across. 4 times 2 is 8, and 5 times 1 is 5. There's our answer. So that is the supergiant 1 method. All right, so let's do another example with 2.5 divided by 3/4. So go ahead and pause the video and try to work that one out yourself using both methods, the common denominator and then the supergiant 1. Go ahead and pause. All right, so if you worked it out, then you changed 2 1/2 to 5/2 divided by 3/4, and we're going to rewrite those as common denominator. Least common denominator is 4. So since the LCD is 4, we're going to do 10/4 divided by 3/4. So the answer is 10/3. Okay, supergiant 1. We have 5/2 divided by 3/4. And the supergiant 1 is going to be the reciprocal of the denominator. You can just put a rectangle if you're not good at the supergiant 1. And there we go. So that's 20 over 6. And 20 over 6 is equal to 10/3. Okay, if you wish to put this as a mixed number here, you can go ahead and put 3 1/3. But this is a perfectly good reduced fraction. You can leave it as it is.